Okay, so 146 is even. So let's try 2 times what? 73. Now 73, what goes into that? 3? Nothing? Let's try. 73 divided by 3. Oh, wait. Let's try 7. Doesn't look like it works, right? Okay, so 73 is prime. So that means this number has no pairs. By the way, what kind of root is this? If there's nothing, it's a square root. But number 2 is actually a cube root. So I'm giving you one of each so you can actually look for those, right? So I'm looking for pairs, but there's no pairs for the numbers. Now let's talk about the variables. Y to the 6, how many pairs go into 6? So all you gotta do is take that 6 and divide it by 2, you get 3 and 3, right? So 3 and 3 make 6, so that's 2 pairs. So that means x squared is gonna go out. So there's 2 pairs of 3. Sorry, x to the third power is gonna go out because there's 3 pairs of 2, I should say. Okay, 3 pairs of 2. Now what about y to the 7? How many pairs go into 7? Okay, 2, 4, 6, 3 pairs, and then there's a leftover to get 7. Does that make sense? Like 6 plus 1. So 3 pairs with an extra 1. So that's 3 pairs, 1 loader. Okay, that's y to the 7. 3 pairs, 1 loader. Cool. Now, only the circled stuff is going to go out, so x to the third, y to the third goes out to the left. Square root, and on the inside, 146 stays there. There were no pairs. And then my leftover variable is my 1y. Okay, circled stuff goes out, loaders stay in. All right, next one. 7,546. Goodness gracious. Ends in a 6, so it's even, so we can divide by 2. So 7,546 divided by 2. All right, so 2. And what was it? 3773. Now, real quick, did y'all notice out here there was already a coefficient, right? There was a 3 already on the outside. Let's do this. I'm going to circle this 3 outside because it's already there. It's kind of like a pair that already went out. Okay, now let's break down 3773. What do you think goes into that? We always try 2. Well, it's not even. Let's try 3. 3 go into 3,773. Do you know? 3 doesn't. What about 5 won't because it doesn't end in a 5 or a 0. What about 7? It does work. So 7 goes into 3,773. 7 times 539. All right, what do you think goes into 539? Let's try 7 again. Why not? So divide by 7. It works. 7 times 77. And what about 77? 7, right? 7 times 11. Now, do we have any triplets? Since we're talking about cube root, are there any groups of 3? 7, 7, 7. Yeah. Circle that. 7, 7, 7. I can cross one of, sorry, I'm going to cross 2 of them out. So what's going out is 7, and what's already outside? 3. So don't forget to multiply 7 times 3. So what do I get? 21 cube root. Put the little 3 there. And what are my 2 leftovers? 2 times 11 is 22. All right? So 21 cube root, 22. All right. It's Friday, so make sure your name's on that. Pass to the front, please. If you're doing a test, put test on yours. Pass to the front. We're gonna do notes. So, how many of y'all thought the last 4 days was kind of hard with all the factor trees? So, y'all want to do something harder or easier? All right, this should be easier. So, and the notes can be a little bit short if I don't have to keep asking you to take out the headphones, that you already know that. So, take out the headphones, please. So, for adding and subtracting, okay? So, first off, let's remember how to add and subtract variables. If I had 2x plus 3x, what would I get? 5x. Not squared, just 5x. You see how the x stayed the same? When you're adding, you're only adding the coefficients in front. Same thing with subtracting. 7x minus 5x is 7 minus 5, 2, x stays the same, right? Now, if they don't match, 5x, 3y, thank you. No, don't do that. Thank you. So 5x plus 3y is not 8. It's not 8xy. You cannot add them if they're different terms. So when they're different, just rewrite it. Like 5x plus 3y was it. That was it. Okay. Now that was variable. That's old school. Hopefully we already know that. But now let's talk about radicals. Same exact idea. Okay. So with square roots, you know me? Write it down. So 2 square root of 3 plus 5 square root of 3. What's 2 plus 5? 7. and then the square root stays the same. So 7 square root of 3. Now, if there's no number in front of the square root, what do I put? Okay, now, 4 plus 1, 5, square root stays the same, 3. Okay, easy? Now, what about subtraction? Same idea. 5 minus 3, 2, square root stays the same, 7. Okay? Over here, there's a 1 here, right? So 2 minus 1, 1 square root of 3. Now, you can write 1 square root of 3, or just square root of 3. Okay? That's pretty much it for the notes, but I want to show you there's some tricks in here, just for y'all, because you know why? Tricks are for kids. All right, now, 2 plus 4, what do I get? 6 square root of what? All right, silly rabbits. Now, what's this? 8 minus 4 is 4, square root of 5. All right, next. 3 minus what goes here? 3 minus 1, so we got 2 square root of 2. All right, what's weird about number 4? Square root of 7, square root of 5. Someone's going to write 5 square root of 12 or something. Okay? You cannot add them if they're not the same square root. Right? So, rewrite it. 3 square root of 7 plus 2 square root of 5. Just rewrite. Now, number 5. Whoa. Alright. Number 5. Now, there's 3 terms. I can only add the same square root sign. So, I got a square root of 3, a square root of 3. Those can combine. The square root of 5, it doesn't add. It's just going to be brought straight down. Okay? So let's add these, or in this case, subtract these. 2 minus 3, negative 1. Hold on, negative 1. Square root stays the same, so square root of 3. And then the one that's different, bring it down. That's the answer. You can only combine like terms, unlike terms come down next to it. Okay, what about 6? 8 minus 7, 1 square root of 2. Okay, so 8 minus 7 is, and then the square root stays the same, right? 1 square root of 2. Now, on number 7, they're all the same, right? Square root of 2, square root of 2, square root of 2. So they all can combine. So what's 3 plus 4? 7 minus 8. What's 7 minus 8? Someone else is sleeping on this row this time. All right, negative 1. Negative 1 what? Square root of 2. All right, 8. 10 minus 5. 5 square root of 5. All right? Now, here's the trickiest tricks that you could be tricked with. Square root of 2 plus square root of 18. Are they the same square root? They're not. Now, up there we just left them alone, right? Because you couldn't do anything with them. But I bet you could do something with the square root of 18. Didn't we learn a trick or two about breaking it down? Let's break down that 18. What times what? 2 times 9. 9 is what? 3 times 3. Now, do I have a pair? Pair of 3. How do I write this? Rewrite this, actually. The pair goes out. 3 square root of 2. Okay, so now I'm going to bring this down. So I have a square root of 2 plus 3 square root of 2. Now, can I add them? Hey, now they match. So I have a 1 square root of 2 plus a 3 square root of 2. 4 square root of 2. Yeah, that was the trickiest trick you can be tricked with, silly rabbits. Crazy loops. Or tricky tricks. Whatever cereal it is. Now, number 10. Can I subtract these? Not right now, but let's see. Maybe. What times what? 3 times 9 is what? Oh, sorry, and then 9. Do I have a pair? So 3 goes out. The other 3 goes in. 3 square root of 3 minus square root of 3. So 3 minus 1 is 2, and then square root of 3. So sometimes it looks like you can't do anything. Maybe you need to break something down, and it might work. Now, if you had that cube root assignment from the last few days, you did the front side, that's fine, turn it in. This should be a softball. It should be not that hard, right? Some of y'all, I'm going to have you do some corrections, but let's work on this today. All right.